Hello everyone. My name is Ashutosh Sharma and today I will be presenting my NLP and machine learning project called Medicines Drug Review Sentiment Analysis. The objective of this project is to automatically analyze patient drug review and classify them as positive or negative using natural language processing and machine learning technique. In today healthcare industry, thousands of reviews are posted online every day. Reading all of them manually is impossible. Therefore, this system helps doctor, pharmacists, healthcare companies and patients quickly understand overall sentiment and make better decisions. Now we will see the business problem. Patients have large number of reviews on websites such as drugs.com. These reviews contains valuable information regarding like drug effectiveness, side effects, user satisfaction and treatment outcome. However, reviews are unstructured text. Huge volumes of reviews, manual analysis is time consuming. Why is it important? Healthcare companies can monitor drug performance, identify side effects early, improve customer satisfaction. Also, patients can understand real experience making informed decision and doctors can understand treatment effectiveness. Now, we will see with the dataset description part. Now, let's discuss the dataset use. Dataset contain more than 2,15,000 patients review collected from the drugs.com. Columns include drug name, condition, review text, rating, date, and useful count. The most important column is review because it contains the patient actual experience. Now, target variables. The dataset did not directly contain sentiment labels. We will see with the PPT part. Therefore, I created them using like rating. The positive sentiment higher with the 7, negative with the lower with the 4, neutral 5 to 6. Neutral reviews were removed because they do not strongly express positive or negative emotion. This converted the problem into a binary classification problem. Now, we will see with the Python work. First, we have import the libraries like pandas, numpy, matplot, cburn, sklearn, and ltk. Purpose: data handling, visualization, NLP processing, and model training. First, we load the dataset. We do the exploratory data analysis like head function, info function, and describe function. Like this help to understand like number of rows, missing values, data type, and distribution. Then we will go with the text pre-processing part. Like raw reviews cannot be directly fed into machine learning models. Therefore, we perform pre-processing like HTML removal, converts to lowercase, remove URLs, remove punctuation, tokenization, also removal of stop words. Removal of stop word, this reduce noise and improve model equality. Then we will further go with the feature engineering part. Machine learning model cannot understand text directly. Therefore, text must be converted into number. We use TF-IDF vectorization function. In Python, it have a TF vectorizer. Like we configure with the max features, n-gram range, min df, and max df. Like positive statement like works great with the negative like side effect. This become numerical vector. Then we will go with the model building part. We build the model like logistic regression, naive Bayes, and linear SVM. First, we will go with the logistic regression. Logistic regression advantage with a fast, accurate, and gives probability score. Like accuracy with the 92 to 94%. Naive Bayes advantage were very fast, but accuracy felt low, 88 to 91%. With the linear SVM advantage was strong text classifier, accuracy with 92 to 94%. After comparison, logistic regression was selected because it achieved high accuracy while also providing probability score. Now, model evaluation. Confusion matrix and evaluation outputs from notebook. Accuracy, overall correctness, precision were how many predicted positive were actually positive. Recall how many actual positive were identified. F1 score, balance between precision and recall. Results like accuracy with the 92 to 94%, F1 score above 0.92%, AUC score around 0.97%. Then we will also done a cross validation To ensure the model generalized well, I used five-fold cross-validation. Result were mean accuracy were 93.3%, standard deviation for 4.48%. This indicates stable performance. Key insights we will see in next slide. Key insight like positive indicators like work, great, helped, improved, relief. Also, negative indicator like side effects, nausea, headache, worst, painful. This demonstrate that the model learned meaningful healthcare related pattern. Then we learn the end-to-end pipeline. First raw reviews, then cleaning part, then TF idea factorization, then machine learning model, then prediction, then positive negative output. Now we will see to the website part. Sidebar like project overview, algorithm, weather, vocabulary size, accuracy. We will see the single prediction like here you can see the positive sentiment because the review were positive. Confidence score is also a high. Now we will go with the negative part. Here you can see it shows a negative result. Now we will come back to our model with the PPT slide. Like steps we deploy with the help of Streamlit. First we train model, then save model using pickle.pkl file, build Streamlit application, push code to GitHub, connect GitHub with a Streamlit cloud and deploy publicly. Users can access the application directly through a web browser. The main challenges were large dataset processing, solved using optimized TF-IDF settings, text cleaning complexity, created pre-processing pipeline, model selection, compared multiple algorithm, deployment issue were resolved, package version conflicts in Streamlit, my learning well, NLP pre-processing, feature engineering, machine learning evaluation, model deployment, end-to-end project lifecycle. My conclusion, in conclusion, I successfully deployed an end-to-end NLP-based sentiment analysis system for drug review. The project processed more than 215,000 reviews and achieved approximately 93% accuracy using logistic regression and TF-IDF. The solution was deployed as a live Streamlit application that allow user to perform both single and batch sentiment prediction. Future improvement include integrity like BERT, multi-class sentiment classification, condition-wise analysis, and Power BI dashboard. Thank you for watching.